Hi there! Welcome to this tutorial on how to use FORCAT Capture and Analysis Toolkit. FORCAT is a research tool that can both collect and analyze data from various web platforms. In this tutorial we will cover how to analyze a dataset. After having queried a data source, it is possible to immediately download the results and inspect or manipulate the data with other tools than FORCAT. However, FORCAT also offers a wide range of options to process the data you just collected by using the tool itself. This can include conversion, extracting metrics, text mining, visualization, or other processes. We refer to the little scripts that produce these results as analytical processors or simply processors. FORCAT's processors are modular, meaning that they can easily be added, changed, or deleted without affecting the rest of the tool. In effect, they are simple Python scripts that process the parent data set in some way. For those interested, we'll make a future tutorial on how to write a processor. These instructions are also available on FORCAT's GitHub page, and see the link in the video description to access those. For now, however, we will be focusing on using processors from the front-end perspective. As an example, let's take this dataset of Reddit posts from the subreddit r/WallStreetBets. In this case, with comments containing the words GameStop or GME from December 31st, 2020 until April 29th, 2021. Processors are listed underneath a dataset's overview. On this FORCAT, they are subdivided in different categories like conversion, filtering, networks, and so forth. Note that some processors are universal, so they appear with output from any kind of data source, while others are specific to one data source. Each processor has a title and a description. Certain processors also have a references button, which you can see here. And clicking on that leads you to links concerning this processor's functioning. For instance, this Google Vision API processor has links to the Google Vision API documentation and the pricing. But these may also include academic sources. Let's go over several cases of processors to show some functions. Firstly, let's try to make a histogram of weekly posts from this dataset. Under the post metrics category, we find the processor count posts. As you can see, you first need to press the options button to run this processor. In this case, we can choose a time interval, overall, or per year, month, week, or day. And we can also check mark this button to make time series continuous. To read more explanation, you can also hover over the question mark to the right. And with these explanations, we try to render explicit or unblackbox the underlying code of this processor. Now we can press run to run the processor. In this case, it is first warning us that this is a very large dataset with over 500,000 items. In this case, that's fine because it's a very lightweight processor. So we press OK, and then you will see the processor running on the top. It will keep you notified on what it's doing, and also if potentially there are other processors still in the queue waiting to be run. Not the case here. It will also give you several options. It will create a permanent link to this analysis. So if you want to share the results of this processor, you can copy that one. With this button, you can go to the code on GitHub that generated this result. And with this button, you can delete the dataset. We also made sure that the parameters that you used are visible, which allows to retrieve what settings you used in your research steps. When the processor is done, it should show a green box here where you can download the result. In this case, it created a spreadsheet with counts per week, as we expected. But for this tutorial, more importantly, is the button on the right here. And clicking on that expands this drop-down where you can see other processors that can then be used on the result that you just generated. For now, let's try to make a histogram from the counts per week that we just created. And this is possible with the histogram processor you can see here. Again, this has some options, in this case a graph header. So we want to say posts on r/Wall Street bets with GameStop or GME, and let's make that post per week. Then once again we say run. The processor is queued and it generates, in this case, a SVG vector file, which we can again download or open. And now here we see that there was quite an increase in, the 5th week in our data set, and then it dropped off. Okay, that was quite simple, but let us now try something a bit more advanced. Maybe my research concerns the political economy on Reddit's r/Wall Street bets, and I'm interested in what companies are named. Luckily, there's a computational text mining method available that labels words as companies using machine learning to recognize this. And FORCAT offers the possibility to run this kind of computational analysis through the linguistic features module. This uses the SpaCy library, which is a popular text analysis library for Python. It's only available for datasets with less than 100,000 items because it's computationally very intensive. So I've gone ahead and created a dataset with a bit of a narrower date range. So let's press the options button to see what options are available. Well, FORCAT asks us to select what kind of linguistic features to extract. Here I'm only interested in named entities, for instance, where it can recognize Apple as an organization. So I'm gonna checkmark this, press run, and then it shows up on top again, tells that it's preparing the data, it's extracting the linguistic features. This processor will take a while, but luckily, because FORCAT is running on a server, you can just close your browser tab and return to this later. Here we see that the results are being finished and it produces a zip file that you can also import in your Python script with SpaCy on your own. But for now, we are interested in extracting the named entities. And this is possible with the Extract Named Entities module. Pressing options will show us what entities we want to extract. So here I'm only interested in the organization entities, so names of companies, agencies, or institutions. And what's also an interesting feature of this processor is the top check mark, the Add Extracted Entities to Source CSV option. And this will actually update the source dataset, so the dataset we started with, and add the recognized organization entities to the rows of the post in the CSV. So we'll create a new column with those organization entities. And it can be helpful for diving back in that data and maybe only filtering on posts where an organization like the New York Stock Exchange was mentioned. Okay, let's run the processor. It's queued again, it's unzipping the SpaCy docs. And at some point it will produce a CSV file with the ranked recognized organization entities. Well, here we see, of course, that GameStop appears the most because this was the word that we queried for. Then also AMC, WSB for Wall Street bets, Derive Wealth, New York Stock Exchange, Amazon, and other organizations mentioned. So maybe you want to visualize this, or you just want to have this as an exploratory finding. And to illustrate, in the source file, now we can also see a new column with entities, listing all the entities that were recognized in the posts of the dataset that we queried. Alright, lastly I'll show a third final example. It's a bit more simple, but gives some more insight into the possibilities of FORCAT. I want to create an image wall of images that are often used in these posts. To do so, I first need to run the top images module. Here again, there's an option to add the image URLs to the source CSV. So again, creating a new column. I'm going to run it without now. Then it creates a CSV file listing the URLs to specific images and how often those were posted. And then FORCAT also has a download images module that takes those URLs and downloads them. Here you can set a maximum amount of images to download. Well, I'll just stick with the default 100 now. And again, I can add a status of these download results to the top images CSV file. I don't want to do this for now. I'm just clicking run and it's queued again. So then it will loop through all the images that it can download. And at some point it will have retrieved most of them. Not all of them can be retrieved. Sometimes it's an image that's offline. But here we see that we managed to download 89 of the 100 images that we requested. So this produces a zip file with all the images included. But now I am gonna create an image wall. And the options reveal various settings again. Here I wanna just use all 89 images we downloaded. They should be sized as squares. And I'm gonna sort colors by dominant. And after a while, the processor will finish, in this case creating a PNG file of 3 megabytes. Again, with all the parameters listed here. And if we open the PNG file, we can see the sorted images, revealing that the posters on Wall Street Bets mostly posted stock charts with some other random images of a pizza and a very muscular bull apparently. Thanks for listening. This has only been one overview of FORCAT's processors. They are constantly being improved or new ones are being added, and we highly encourage others to add their own ones. But hopefully this short overview has given you enough to get started.